So for example 1, the length of a rectangle is 3 centimeters more than twice the width. So here's my rectangle. I have that the length of my rectangle is 3 centimeters more than twice the width. So the length plus 3 equals 2w. I know that the perimeter of my rectangle is 90 centimeters. And I want to find the length and the width of my rectangle. Well, we have to remember perimeter equals 2 lengths plus 2 widths. Right, so here's my length, here's my width. If I add those up, I will get my perimeter. So I'm going to go ahead and take this main equation and substitute in. I have 90 equals 2 lengths plus 2 widths. But I don't have a single variable solved for. Let's go ahead and solve for L. I get that L equals 2W minus 3. So now I could substitute this in for L in my equation over here and solve for W. I now have an equation in one variable. So I have 90 equals 2 times 2W minus 3 plus 2W. So I have 90 equals, remember we got to distribute, 4W minus 6 plus 2W. I add 6 to both sides and combine like terms. 96 equals 6W, so W equals 16. So I just figured out my W equals 16. I can now go back to this equation over here and substitute in to find my length. So length equals 2 times 16 minus 3. That means length equals 32 minus 3, which is 29. And if I wanted to check my answer, I could say 2 times 29 plus 2 times 16 is my perimeter. My perimeter is 58 plus 32, which is in fact 90. And remember that all of these measurements should be in centimeters. Keep track of your units. Good job. Next, Thomas Flanagan has $40,000 to invest. He will put part of the money into an account paying 4% interest and the remainder into stocks paying 6% interest. The total annual income from these investments, so annual meaning yearly, should be $2,040. How much should he invest at each rate? So a couple key factors. Remember that interest equals principal times rate times time, where time is in years. But in this case, because our time is 1 year, right, annual, every year, time is 1 year, we can kind of ignore that part. So I've got my principal. We're going to use a table to help us organize our information. I have a total of $40,000. I have two different accounts. So I've got my different rates that I'm going to express in decimals. And then I have my interest, which is going to be in dollars. Well, I know total principal, I've got 40,000. And total interest, I'm supposed to get $2,040. So let's say I put X amount of money in the account paying 4% interest. So if I've got X times 0.04, my interest is 0.04X. Well, how much do I have left over? If I have $40,000 and I take away X, that leaves me with 40,000 minus X. And as you can see, if I was to add these two together, I'd get my total. And that's going to be the amount I'm investing at 0.06%. So I'd have 0.06 times 40,000 minus X. So these interest in two accounts should equal $2,040. These are equivalent. Because they're equivalent, they're equal. I can use these to set up my equation. 0.04x plus 0.06 times 40,000 minus x. I put the parenthesis in the wrong spot. Darn. 40,000 minus x equals $2,040. So I have 0.04x plus 0.06 times 40,000 is 2,400. 0.06 times negative x is minus 0.06x. And remember, if you don't like working with decimals, you could have multiplied both sides of this equation by 100 to get rid of the decimals, but I really don't mind working with them. So I'm going to subtract 2,400 from both sides. That leaves me with negative 360 on the right. I can combine my like terms. 0.04x minus 0.06x is a negative 0.02x. If I divide by sides by negative 0.02, thank goodness those negative cancels, right? Because you can't have a negative out of money. I get x is 18,000. So I invested 18,000 at 4%, and then I invested 40,000 minus 18,000, which is 22,000, at 6%. So this is our final answer. These two parts right here. For example 3, a chemist must mix 6 liters of 40% acid solution with some 60% solution to get a 50% solution. So how much of the 60% solution should be used? Okay, so we're going to have liters of solution. I think black shows up better. We're going to have liters of solution. We're going to have the percent of acid as a decimal. And if I take the liters of solution times the percent of acid, that's going to give me the liters of pure acid. So I've got 6 liters at 0.40, so 40% is 0.40. That would give me 2.4 liters. Again, I'm multiplying these two to get to this. And then I have some unknown amount, like some. How vague is that? Some. I've got some 60% solution, so I've got 0.6x. And I need 6 plus x, once I mix them all up, to make a 50% solution. So that would give me 0.50 times 6 plus x. So these two should be equivalent. This is how we're going to set up our equation. So I've got 0.24 plus 0.6x equals 0.5 times 6 plus x. Now I go ahead and distribute. I've got 2.4 plus 0.6x equals 3 plus 0.5x. I'm going to go ahead and subtract 3 from both sides. That gives me a negative 0.6 plus 0.6x equals 0.5x. I'm going to move my decimal to the other side. I'm going to subtract, and it doesn't matter if I move to the decimal to, if I move the variable, if I left the variable on the left or the right, as long as I follow the rules of solving for x, we're going to get the same answer. So I'm going to subtract 0.6x. I get negative 0.6x equals negative 0.1x. Wait, negative 0.6 equals negative 0.1x. And I'm going to go ahead and divide both sides by negative 0.1, and this is great, right, because I couldn't have a negative amount of acid. So I get 6 equals x. So I would need to use 6 liters of the 60% solution with 6 liters of the 40% solution in order to get to the 50% solution. So setting up a table is always really helpful as you work through these problems. So let's say your uncle has 26 coins in his pockets that are dollars, not dimes, dollars and quarters. So the number of dollars and quarters is 26. These dollars and quarters add up to $17 in value. So the dollars are worth 1 and the quarters are worth 20.25, and that's going to add up to $17. So I need to solve this. This is kind of like when we were finding the perimeter of a rectangle. I need to solve this equation on the left for a single variable and substitute it in. So let's go ahead and solve it for dollars. So I get dollars equals 26 minus Q. So I'm going to substitute this in for D. So I've got 26 minus Q plus 0.25 Q is 17. I subtract 26 from both sides. I get, on the right, I get negative 9 equals negative Q plus 0.25 Q. That's negative 0.75 Q. I divide both sides by negative 0.75, and I get that Q equals 12. So there are 12 quarters. How many dollars are there? Well, remember, dollars plus quarters is 26. So dollars is 26 minus my number of quarters, which is 12. So I get dollars equals 14. Let's check our answer. If I have $14 plus 12 quarters, which are each worth 25 cents, that gives me 14 plus 3, which is $17. Awesome, we checked our answer. So final answer is I have 12 quarters and $14 coins. Last example for this section, let's find the value of x and determine which measure, determine the measure of each angle. So remember that the angles of a triangle add up to 180 degrees. So I have x plus 20 plus 210 minus 3x equals 180 degrees. That's going to give me x plus 20 plus 210 minus 3x equals 180 degrees, which gives me a negative x plus 230 is 180 degrees, which is negative x. If I subtract 230, negative x is negative 50 degrees, so x is 50 degrees, because we got to get rid of that negative leading coefficient. So this angle is 50, this angle is 50 plus 20, which is 70. This angle is 210 minus 3 times 50, which is 210 minus 150, which is 60 degrees. So those are the three angles of our triangle.